I'm Anil Kumar. Welcome to one of the most important concepts where we are going to derive an expression to find angle between radius vector and tangent. And in many examples hereafter, I'm going to use this particular video as the base. The example here is, let P be any point except origin on the curve r equals to f of theta. If phi is the angle between tangent line at P and radial line OP, show that tan phi equals to r over dr d theta. Apply the result to r equals to 1 plus sine theta for theta equals to pi by 3. So what I've done here is that sketched r equals to 1 plus sine theta straight away. And we'll actually first derive the expression and then find the angle. Okay. So what we are given here is that this is O. The point P is on the curve. This is the tangent line. And the angle between the radius vector and the tangent is phi. This is phi. And that's the angle theta, which the radius vector makes with the horizontal initial arm. Now we know this slope of the tangent line, that is angle psi. Now to derive this expression, we can begin with the external angle phi, which is equal to sum of interior angles. Now phi, vertically opposite angle, is this one, correct? So these are two vertically opposite angles. They are always equal. And in a triangle, external angle is equal to sum of interior angles. Therefore, psi is equal to phi plus theta. This is what we get from external angle. So we can write that tan psi is equal to tan of phi plus theta, which is tan phi plus tan theta over 1 minus tan phi tan theta. So that's the formula which you are very familiar with. So we get tan psi, which is basically the slope of the tangent line, correct? Can be written like this. Now we have to find what tan phi is. To get tan phi, what we can do actually is, we can derive the expression for tan psi using the Cartesian coordinates, right? So what I'm trying to say here is that, x equals to r cos theta. And from here, we can write dx d theta is the derivative of this. Applying the product rule, we get r dash cos theta plus r times derivative of cosine theta, which is minus sine theta, right? And we also know that y equals to r sine theta. So dy d theta is equal to the derivative r dash sine theta plus, I'm sorry, I made minus here also. We have to write plus and this is minus, plus r times derivative of sine theta, which is cos theta. So r cos theta. So that becomes the dy d theta. Now tan psi is basically the derivative, right, of the tangent line. So at any point P, which is given as r theta, right? So P is basically r theta in polar coordinate. Can also be written as x and y, where x and y are r cos theta and r sin theta. And what we get is slope at a tangent, slope of the tangent at any point P can be derived as dy by dx or as tan psi. So both are same thing. So this is actually also equal to dy by dx. So from here we get another expression for dy by dx. We could write the ratio of these two, right? That is to say, dy d theta divided by dx d theta, correct? Now, as you can see here, we could write this as dy d theta is r dash sine theta plus r cos theta divided by r dash cos theta minus r sine theta. Now, what we will do here is we'll divide both numerator and denominator by r dash cos theta and see what happens. We'll get this one and then see what happens. So that's kind of a step which is very critical. So what we are trying to do now is r dash sine theta, we are dividing this by r dash cos theta. We'll also divide r cos theta with r dash cos theta. So every term. So the numerator and denominator both are divided by r dash cos theta minus r sine theta divided by r dash cos theta. Perfect. Now the first term, we get r dash cancel away. We get tan theta, right? So we get tan theta here. The second term, we get r over r dash, cos and cos theta cancel. Here r dash cancel, cos theta cancel, so we get just 1 minus r over r dash, sine theta cos theta gives us tan theta. Perfect. Now, if you compare these two equations, equation 1 and equation 2, what do you notice? In the numerator, we have tan theta plus tan phi, and in the denominator, we have 1 minus tan theta tan phi. Now here, do you notice the similarity? R dash and R dash could be written as tan phi. Do you see that? So from comparison, we can say tan phi is basically equals to R over R dash. Correct? What is R dash? R over dr d theta. Correct? So that is how we get our relation, which is right there. So the angle between the radius vector and the tangent phi is related with in this fashion. Do you get the idea? Now this is an extremely important formula to remember. We can always apply this formula, and then once you have this, tan inverse of that will give us angle phi. Correct? So that is how this formula can be utilized to calculate the angle between radius vector and the tangent. Okay? Now many times we are also using reciprocal of this. So let me write down the reciprocal equivalent of this also, which is cot phi is equal to, reciprocal means 1 over r dr d theta. Now this is equivalent expression and will be used many times to find the angle between the radius vector and the tangent. I hope the derivation is straightforward. Now, we'll take up this derivation from here, tan phi equals to r over dr d theta, and then find the angle between the radius vector and the tangent for theta equals to pi by 3 for the given curve, right? So we'll do it in part 2 now. Now, let us try to find the angle between radius vector and tangent for r equals to 1 plus sine theta, where theta equals to pi by 3. We know that tan phi is equal to r over dr d theta. Now here is the polar diagram for the function. Now here we have the cardioid, which represents r equals to 1 plus sine theta. The angle theta is this, which the radius vector makes. The point P makes an angle of phi with the tangent line. Now to get the angle phi, we can find tan phi, which is equal to r over dr d theta. So we are given r as equal to 1 plus sine theta. Differentiating with respect to theta, we get 0 plus cos theta derivative of sine theta. So we get this. Now for theta equals to pi by 3, what is r? R for theta equals to pi by 3 is 1 plus sine pi by 3. We can always use the special triangle, right? Which is 1 to square root 3 for pi by 3. So the value for sine pi by 3 is square root 3 over 2. So we get 1 plus square root 3 over 2. Similarly, let's calculate dr d theta for theta equals to pi by 3. It is equals to cos of pi by 3 or half. Now once you know this, then it is very simple to find tan phi. So from here we get tan phi equals to r. So r is for us 1 plus square root 3 over 2 divided by dr d theta, which is half. This we are doing for theta equals to pi by 3, correct? Now that could be written as 2 plus square root of 3. And from here we can find what phi is. Phi is tan inverse of 2 plus square root of 3. Using the calculator in radian mode, so that's very important. You have to use calculator in radian mode, which is 4 for this setting. So we have tan inverse of 2 plus square root 3 is equal to 5 pi by 12. Correct? So that is how we can very easily calculate the angle between the radius vector and the tangent. So I hope you have understood the importance of this particular relation and seen how we could actually solve such questions so easily. Feel free to write your comments and share your views, and if you really like and subscribe to my videos, that will be great. Thanks for watching and all the best.